Hey, welcome back. We are doing lesson 8.3 today, which is basically the law of cosines. It's basically a cosine formula that can be applied to triangles. You have access to this slide. 8.1, 8.2 is what we've covered so far. Back to our formula chart on the back page. You have all the formulas accessible. I do not have to memorize them. This is the law of sine formula, which is sine A over A, sine B over B, sine C over C. And again, as discussed in class, the capital or the uppercase letters represent the angles, so angle A, angle B, angle C, whereas the lowercase letters, they represent sides, and they have to be in that particular order, which means A is to A, B is to B, C is to C. So there are a total of 3 angle side pairs. We're doing law of cosines today. All the formulas are accessible to you right here. We'll come back to this. All right, you also have access to how the law was derived. It's simply using Pythagorean theorem, but I'm not going to go over it as of now because you're not going to be tested on it or quizzed on it, but we can surely discuss this if we have time during class. And the law of cosine. So let's give it a second and let's analyze what this formula is. This clearly looks more complicated than the law of sine, as you can see, right? It clearly looks more complicated than that. So the way you want to read this is that if you want to find side A, or if side A is what is the unknown, then it can be found by using this long giant formula. Side B can be figured out by adding the square of the other two sides minus the product of all this. And what is that? The product of 2 times side A times side C times cosine of angle B. Similarly, if it is the third side or side C that we have to find, then same formula, we would add the square of the other two sides, the other two that are given, assuming that they're given to us, minus the product of 2 times side A times side B times cosine of angle C. Now, this is all one formula. It's all one formula. It's just written in 3 different styles to accommodate depending what side and what angle are given to us. But if you understand this, it's one formula. See if this makes sense. Angle A, angle B, and angle C. What happens is if side C, let's say we're trying to find side C and side C is the unknown, what this formula says is that hopefully the other two sides and the angle included between those two sides will be given to us. And when that happens, C or C squared can be figured out by what were the other two sides, A and B, and we assume they are given to us by squaring and adding these two other sides, minus 2 times the product of the same two sides, A times B, and then cosine of the angle included. And if you notice, this is actually this formula right here. Let me show you in another way. Let's say we are trying to find side B. So let's say B is what is unknown. Now, assuming that the other two sides are given to us and the angle included between those two sides, b squared can be figured out by adding the square of the other two sides, so a squared plus c squared, minus 2 times the product of the same two sides that are known to us, times cosine of the included angle b. And we have figured out the second one. It just depends on which side is not known. So this formula comes in very handy where law of sine cannot be used. The purpose of this formula also is to find a missing side or a missing angle, just like the purpose of law of sine. This can be used, law of sine can be used to find a missing side or missing angle. This can also be used to find missing side or missing angle. Let me show you one more time. I just feel like showing it to you one more time. Now let's see, because I did not do this. Let's say side A is what is unknown, and we're trying to find this distance. Assuming that the other two sides and the angle included between them is given, a square will always equal the sum of the square of the other two sides minus the product of 2 times the same two sides times cosine of that included angle. And you'll always notice this side and this angle will be the same. If you notice side A, side B, angle B, side C, angle C. And as I've told you before, we were never given these formulas. You have to memorize them. And we always came up with something or the other to remember them. All right, here's an example. Use the given measurements to solve triangle ABC, and obviously they did not give me angle ABC, so let's draw angle ABC to the best of our abilities. Angle C looks like it's 32.2. Now, it does not matter which one I label C, so I'm going to go ahead and label this one C. And then I also label, hey, this is 32.2 degrees. If I call that A, let's call that B, then obviously this is side A, and this is side C, not B, C. And this will be side B, okay? A is given to be 8, and B is given to be 5. So if you look at this, look at the situation here. See how the two sides that are given to me, that's A and B, but then they've also given me the angle that's included between those two sides. So when you're given this triangle and you're like, ooh, solve the triangle, which means I have to find everything else that's missing. What else is missing? I don't know angle A, I don't know angle B, and I don't know side C. So angle A is question mark, angle B is a question mark, and side C is a question mark. Don't know any of those. So that's what we have to find. Now this is not a right triangle, clearly, or at least it's not been given to me, so I'm not going to assume that it is a right triangle. And again, following the same process, since I'm not sure if this is a right triangle, I cannot use Pythagorean theorem, and I cannot use, so no Pythagorean and no SOHCAHTOA. That brings me to the next best thing I know is the law of sine. I was like, oh, there's a formula, a sine formula. But for the sine formula, I need to have an angle side pair given. Do I know an angle side pair here? If you notice, A is to A, angle A is not known, B is to B, angle B is not known, and in C to C, side C is not known. And you can see how we are restricted, that we cannot use law of sine either. Now we know next best thing is law of cosine, which the formulas are available to you. So I'm like, okay, let me try to use that. Now with law of cosine, let me see if I can find side C. So law of cosine says C squared can be gotten by adding which two sides? The other two sides that are given. So a squared plus b squared, and then minus 2 times these two sides, ab, times cosine of angle C. And you see how I have automatically generated the formula without really looking at the formula? But there it is, the third one. Because side C is what I was trying to see, so you can copy that formula down. Now I'm going to start substituting. And this is slightly harder than sine, so look at the calculation part carefully. Angle C is 32.2 degrees. C squared is what I'm trying to find, so I start doing the best I can. Minus 2 times, this is 40, 40 times 2 is 80, cosine of 32.2. And at this point, most of the kids, from my experience, get really tempted. Actually, let me go ahead and add this too. 9 and 89, right? Minus 80 cosine of 32.2 degrees. And again, let me repeat, at this time, a lot of kids are going to get so tempted and go ahead and say 89 minus 80 is 9, and then cosine of 32.2. And right here is when they'll mess up and we'll get totally, completely wrong answer. Because mathematically, this step is incorrect. Let me show you why it's incorrect. This term is the product of AD and cosine of 32.2, and I cannot separate the two. Honestly, at this point, you can plug it into the calculator. 89 minus 80 times cosine 32.2. 9 minus 80 cosine. Oh wow. I'll have to put it in parentheses so that it doesn't start calculating it. Cosine of 32.2. And that turns out to be 21.30. Let me make sure in the settings that we are in degrees. Yes, we are in degrees, and see if I switch. Yep, 21.30. 21.30, and that does not equal C. That's actually C squared, so I'll have to go back and square root. Turns out to be 4.62. 4.62. And as you can see, I have finally figured out side C. Of the three things, we have figured out one, right? Now we still have angle A to find, we still have angle B to find. But while doing that, we did use law of cosine. However, once I did law of cosine, I actually now have an angle side pair available, right? So I do not have to use law of cosine anymore to find the other two angles. So this was step one. Step two now is that now since I have an angle side pair available, to find angle A or angle B, and doesn't matter which one you start with next, A or B, let's try and find angle A. I can use law of sine. Sine of angle A over side A, which is 8. Now to find sine A, cross multiply, so sine A equals 38 times sine 32.2 degrees divided by 4.62. So let me go and find that. Divided by 4.62, I believe, right? 4.62, yeah. And that turns out to be 0.923. I'm rounding it to 3 places. So 0.923. And again, this is not angle A. This is sine of angle A. And I can sine inverse or arc sine 0.923. And that will automatically give me angle A. 0.923. Sine inverse 0.923. And this is in degrees, 67.37. 67.37 is the measurement of angle A. There we go. Right, we have found two of the three things. Now guess what? I have to find the third angle. But you know what? Now I know two of the three angles. So I really don't have to use any law. I can simply use the basic concept that angles of a triangle add up to 180. So if two angles are provided to me, then I can simply go 180 minus the first angle plus the second angle, 62.337, and that will simply give me angle B. I think that's what I'm missing. So 180 minus those two. 32.2 minus 62.37. There we go. The remaining angle should be 85.43. 85.43 degrees, and I did make sure my calculator was in degrees. 85.43. And I have solved the entire triangle. Let me repeat what happened here. We were given a triangle. 3 of the 6 attributes were provided to us. The other 3 were missing. So the first thing I did was wrote down which 3 were missing. And then I decided to try and find C first. Also, I did notice at that time that none of the angle side pairs were provided to me. So we couldn't use law of sine, we couldn't use Pythagorean or SOHCAHTOA because it wasn't a right triangle. So the next best thing we knew was law of cosine. Law of cosine, this is the one I picked because I labeled the triangle depending on how it was given in the question. Once I labeled it, then we figured out angles, the side C is what is missing. So I picked the third formula because the third formula is what helps us find side C. Once I did that formula very carefully, I was able to find one missing side. Once I had this side, I actually had an angle side pair given. So then I used the law of sine to find one of the angles. And once I had two angles, I just used this concept and found the third angle. There's another example here. See if you can practice this. I want to show you one more example. There, look at this one. Use the given measurements to again solve angle ABC, which means I have to find everything else that's missing. If you notice angle A, angle B, and angle C, you can clearly see This is side C, this is B, and this is A. All three sides are given, and all three angles are what are missing. Angle B and angle C. Those are the missing components. All three angles are missing. And again, all three angles are missing. I have no idea if this is a right triangle, and I'm not going to assume that. And hence, I'm not going to use Pythagorean or SOHCAHTOA. The next best thing I know is law of sine. Now, to get started with law of sine, I need to have an angle side pair given, which, as you can see, clearly is not given. None of the pairs are available to me because in all three pairs, the angles are missing. Then we move on to law of cosine. Now, law of cosine, you'll be like, which one do I pick? Because this is to find the three sides, right? And all three sides are given to me. So this time we're going to use law of sine not to find any of these sides actually. We're going to use it to find angles. Angle A, angle B, angle C. And it does not matter which one we start with because all three are missing. So let's start with angle A. Let's try and find angle A. And the only alternative we know as of now is to use law of sine, which is basically law of cosine, which is the cosine formula. So let me get that first formula and see how I can apply it. And these computations are also going to be tricky because they require nice level of computational skills. Well, let's do the first one. I just copied it there, the very first one as I spoke. And again, I've told you the strategy. It's not too hard to remember it. If I copy the first one, so a squared is the sum of the other two sides minus 2 times the same two sides times cosine of the very first angle. Let's start substituting. 8, 9, 7, 2 times 9 times 7 times cosine of A. What's the unknown here? Angle A itself. We know everything else, but we don't know angle A. So this is a backwards type of question. 64, 81, and you cannot use calculator at this point. Because the right-hand side, if you put in entire right-hand side, since cosine A is unknown, calculator will not be able to give you anything. If I would have known angle A, if this was an actual value, like a 60-degree angle or a number, then we could have put the whole thing into the calculator. It would have computed for us. But if we give it something where one value is missing, like if you put in 2x into the calculator, it's not going to give you anything because unless an x value is fed into it. Other than that, you're giving it an unknown. Minus these three multiplied to 63 times 2, 126, cosine of A. Now I'm going to add these two. And people will be very tempted to subtract these two. That will be incorrect because this is one whole term and I cannot separate them yet until I get to the very last. So the next best thing you can do here is subtract 130 from both sides. Negative 126 cosine A. 64 minus 130 would be 6 and 6. Yeah, 66. But it will be negative. Now the next thing I can do is, and the only thing I can do is, remember we're trying to find angle A, so I have to isolate cosine A. Negative 126, I'm going to divide it by that to get rid of it from here. Negative 126. All I'm left with on the right-hand side is cosine A. Two negatives are going to cancel each other out. Let's find the decimal value. 66 divided by 126. 0.523. 0.523. And I'm this close to finding angle A. Up to cosine inverse. So angle A is basically cosine inverse of 0.523. Let's go find it. And I am in degrees, so 58.47. Angle A turns out to be 58.47. Yes, that was a lot of work. We did find our first missing angle. This was first step. Requires some practice. Now that I have that angle A, 58.47, do I have an angle side pair? Now I actually have an angle side pair. I know angle A and I know side A. So my second step would be that I can use law of sine over 8 equals, what's next? I'm going to get to B, so sine B over side B, which is 9. I'm going to cross multiply these two, put it over that. So sine B equals 9 sine 58.47 divided by 8. Well, let's go find the value. 58.47. 9 times 58.47 divided by 8. There we go. 0.959. 0.959. And that is the value of sine B. So angle B can easily be found by sine inversing the value. Sine inverse 9.957. 73.14 is the angle. 73.14 degrees is angle B. So I found this one as well. Now that I know two angles of the three, I do not have to use any hi-fi formulas. 180 minus the sum of these two, 3.14, should give me the third angle. And 180 where was I? 8 and then 4, right? And I can check it. I think this is 3. 48.39. And if there are any errors, please find them and let me know. 3 steps, and I was able to solve the triangle. Yes, a lot of computation. What else? Now we need to actually show you word problem, right? Wouldn't be nice. It's a pretty good word problem. I like it. But let's see if you like it or not. A pilot is flying from Houston to Oklahoma City. So I've marked it for you. To avoid a thunderstorm, the pilot flies 28 degrees off the direct route for a distance of 175 miles. He then makes a turn and flies straight on to Oklahoma City. To the nearest mile, how much farther than the direct route was the route taken by the pilot? So he was supposed to go this blue route, Houston to Oklahoma, right? Which was 396 miles. That was the initial distance between the two cities. But because of a thunderstorm, he had to deviate to this pink route. And he deviated for 175 miles and then decided to go towards Oklahoma City. So he actually traveled the pink and the green route instead of the blue route. So clearly pink plus green is going to be more than 396. The question's asking me how much farther than the direct route was the route taken by the pilot. So pink plus green basically is what he took. They're asking how much, this is greater than the blue route for sure. They're asking by how much. So I have to find the green route. This is the question mark. We don't know how much he traveled once he turned around. Once I find this green route, then I can add the pink and the green and then subtract 396 from the sum of that to find how much farther he had to go. Okay, let's look at it again. Oh, it's kind of provided us the answer. There's not enough room here. Oh, let me try to work it on the side. So yada yada yada. Okay, so we do have a triangle constructed. Let's construct it again without so much stuff on it. So 28, 396, 175 degrees. That's the only piece of information given. What do we have to find? This side, let's call it x. Okay. This does not look like a right triangle, so I'm not going to assume, so no SOHCAHTOA, no Pythagorean. You would want to say this, let's just use Pythagorean because we already have two sides, but we can't because we don't know if this is a right triangle. Most likely it's not a right triangle. Then we're like the next best thing is the law of sines, for which I have to have an angle side pair. If you look at this triangle carefully, we do not know any angle side pair. I mean, we know two sides and an angle, but not an angle side pair. And let's see if we can use cosine, law of cosine then. If you notice again, two sides are given, and the angle included is also given. That's also a good sign that it's law of cosine. That's one of the criteria to determine if you don't want to go through the process of elimination, that it's law of cosine. And we can label it however we want to, A, B, C. So this is B, that's A, and this is C. And you can see we are trying to find side C. And that also tells you that pick the third one listed there. C squared equals A squared plus B squared minus 2ab times cosine of A. Again, you don't have to memorize it. It's the third one. Why did I pick the third one? Because after labeling all the sides, I figured out it's side C that I'm trying to find. Start plugging in some numbers. These are going to be gigantic numbers. Minus 2 times A times B times cosine of C. And thankfully, if you notice, everything on the right side of the equation is a known number. So we can directly put it into the calculator. Let's do it. Plus 396 squared minus 2 times 175 times 396 times cosine of that angle, which was 28 degrees. And you see that? It's 65064.46. 0.46. And again, that is not C, that is square of C. So we'll have to square root both sides. And once I do that, then I'll get C because square and square root cancel each other out. So let's go ahead and do that. Six 4.463. 255.07-ish, so about 255 miles. 255 miles, which means this green distance, this one, was 255 miles. So I can clearly now get the total distance he traveled. The total distance he traveled is basically the pink route plus the green route, right? Pink was known, green is now known. That adds up to 430 miles, right? But its direct route was 396 miles. So you can clearly see that he went, 96. He went extra 34 miles than he would have if he didn't have to avoid thunderstorms. And we all know airplanes have enough extra gas to go 34 miles extra. Now, if it's a different situation where then you have to go another 200 miles or something because of whatever, then that's a different situation. We were actually once stuck in a thunderstorm where the plane just kept going round and round in the air for the next 45 minutes, but didn't run out of gas, so that was good. So those are the word problems. Here, I want to show you like which one to use. Now that you know both law of sine and cosine, which one to use? Law of sine is useful when two angles and one side are given. Any two angles and one side is given. We can quickly use law of sine. And then two sides and a non-included angle are given, which means two sides. Let's say these two sides are given, but a non-included angle, which means not this one, any other besides this, either this one or this one. And again, as I said, I mean, honestly, the way I look at it is that, do I know an angle side pair? If you know an angle side pair, go ahead and use law of sine. Law of cosine, on the other hand, is used when all three sides are given, just like the example we did. let's say 7, 8, 9. Let's say all sides are given. I showed you an example for that. Or if two sides and the included angle are given. Two sides and the included angle are given. And we did both such examples. We did an example like that. We did an example like that. Or bottom line, for our purposes, if you can't use anything you know, law of sine or Pythagorean or SOHCAHTOA, you should be able to use law of cosine. You practice. This slide is oh, slightly messed up. I'm sorry. I should be able to fix it in the original slide, but I've solved this one and all the answers are known to you. See if you can practice this one using what you've learned in this video and get these answers. If you get these answers, then you're good to go. Once they solve the triangle, which means anything that's missing, this is missing, this angle is missing, and that side is missing. So all the answers are given to you. All right. Good luck with that. If you have any questions, ask me in class. Hopefully this was helpful. I will see you later. Bye.